Dear colleagues, welcome to the first webinar of the Standing Committee for Gender Equality in Science. My name is Catherine Jamy. I'm a researcher at the French CNRS, and I am the chair of the Standing Committee for Gender Equality in Science. Since this is the first public event we are organizing, please allow me to explain to you in a few words what the Standing Committee for Gender Equality in Science is. The SCGES is an independent committee formed in 2020 by 9 international scientific organizations, most of which are full members of the International Science Council. These founding partners had worked together on the International Science Council supported project, a global approach to the gender gap in mathematical computing and natural sciences, how to measure it, how to reduce it. This project became known as the Gender Gap in Science project, and many of you may have heard about it. At the time when I'm speaking to you, the Standing Committee for Gender Equality in Science has got 19 partners, 17 of which are International Science Council Union members. They represent scientists around the world brought together across disciplines to promote gender equality in science. The aim of SCGES is to ensure liaison amongst international scientific unions to foster gender equality and the implementation of recommendations of the Gender Gap in Science project, especially in the communities that the scientific unions represent. We have also issued recommendations to safeguard gender equality in science in the context of the COVID-19 pandemics. SCGES intends to actively cooperate with policymakers and international organizations, first and foremost ISC, for the promotion of gender equality in science. So basically, what we want to do is to encourage and systematize the exchange of information on gender equality and women in science among scientific unions. The present webinar, the first of the series, is jointly organized by the International Mathematical Union and the International Council for Industrial and Applied Mathematics, and it will discuss the situation of women in pure and applied mathematics, but also the actions taken over the last decades to improve the situation of women in mathematics and to reduce the gender gap. I wish you a good webinar. Thank you.
So we are live. So I hope you've been able to hear the welcoming words from Catherine Jamy, the SCGES chair. And let me introduce myself. I'm Marie-Françoise Roy, and I'm together with Carol Woodward, who are the two organizers of this session, which is the first session of this webinar series from SCGES, and the topic is gender equality in mathematics. Yes. So let me just tell you a little bit about what's going on with this webinar. So we have two parts, first hour and second hour. In the first part, we're going to have a presentation on the gender gap in mathematics and applied mathematics by Colette Guillopé. And in the second part, we are going to have a panel about the 50 years activities of the Association for Women in Mathematics. Okay, so about who is attending? Well, many people are attending, more than 422, because 422 is when we made the site a few minutes ago, but we had even more registered people at the last minute. And you can see the geographic distribution. And so, of course, there are many people in Europe, but also quite a few in US and in Asia, and also in Africa and Latin America. So that's, I think, a very good distribution. We've seen also what's the proportion of genders. So we have a very vast, big proportion of female, a little like maybe around 15% of male, and then several, very few people answered in non-binary, and several people just didn't give an answer, so we don't know who they are. And we've been also asking for the what is the thematical balance, and we see that about half of the attendees are from mathematics, others prefer to precise applied mathematics, and then we have also people from physics, chemistry, computer science, statistics, history of science, biology, education, psychology. Then a lot of different categories were grouped into one, and also people who gave no indication on their topic. And finally, we also asked about the state of career. And in fact, we observed that we have really a lot of diversity from, say, undergraduate students, PhD students, postdocs, assistant professor, associate professor, full professor, emerita professors, also some administrative staff, head of departments, etc., etc. So it's really extremely diverse. And it's really encouraging for us also to see that this interest for gender equality in science is really interesting for people at all stages of their careers. Okay. Okay, so now I think it's time to start with the presentation of Colette Guillopé. So let me upload the slides, and then I'm going to introduce the talk. Okay, so the slides are here. Okay, so in fact, Colette Guillopé is a professor of mathematics, and she has been involved during decades in various organizations for women in mathematics and women in science in France and also in Europe. And she was also a very active member of the Gender Gap in Science project, and that's the reason why she was invited to give this talk on the gender gap in mathematics and applied mathematics. So, Colette.
Okay, thank you very much, Marie-Françoise. Okay, next one, please. Okay, so I'm going to talk some about the Gender Gap in Science project. It's been a project which has been funded by ISC and which was led by IMU and UPAC, so mathematicians and chemists, and during the year 2017-2019. And there were many organizations, all disciplines. And sorry, what's going on?
No, you didn't explain what ISC is.
Oh, International Science Council. Okay, thank you. Next one. Okay, so during our work on that project, we had a number of workshops, meetings, and there were a number of studies. Okay, we've got back. Next one. And we published a book, Marie-Françoise. Okay, thank you very much. Then you could find, and you can print on demand. And so it's a fairly long study and a lot in it, really a lot. So the title is a global approach to the gender gap in mathematical computing and natural sciences, how to measure it, how to reduce it. So next one, I'm going to give more details about what there is in the project. There are 3 parts. There's a global survey scientist with 32,000 answers. There's an analysis of academic publications. Millions of publications have been analyzed since 1970. And there's a database of good practices where 68 activities have been analyzed. And at the end, we issued some recommendations for instructors and parents, local organizations, scientific unions. So next one, please. Okay. So I'm talking about the global survey of scientists. They were half women, half men, 130 countries, 8 languages. So it was done by the snowball way, like you tell your friend that there's this survey to fill, and then the friends ask your friends and so on. So it's not a statistically representative of all the population of scientists in the world, but because there are so many answers, you could, and from different countries, and then you could see there are really, people have to say something about what's going on in their career or is their study. So the women's experiences in both educational and employment settings are consistently less positive than men's. And we had a new kind of recent chapter. We started that in 2018, and about sexual harassment. And over a quarter of women respondents across the sciences reported personal experiencing sexual harassment at school or at work. Next one, please. I say a few words about the analysis of academic publications. So there's what we could see, there's a steady increase of the proportion of women authors of scientific papers. So this study for mathematics has been done from the Centralblatt, how do you say, set of, all the publications are listed there. And it has been done in astronomy, it has been done in chemistry too, and physics. And we couldn't do it really in biology because there are a lot of journals which you have to pay for. So it's very difficult to have access, and then you cannot reproduce the studies either. And you could see that the 2 lines, female authors, has been going up as the same way as all authors, started in the 70s, there were very few, and then there are more now, way more. Next one, please. Okay, we studied the productivity gap. So, and you could see the blue line, the bottom one is for the years 1970, 74. So we studied in 10 years, about 10 years or 6 years. And you could see that the productivity of female scientists has increased over time. And it's about now 85 to 95% of that of male scientists, depending on the discipline, on the field. Thank you. Next one. Okay. And we studied also the publications in top journals. So it has improved in astronomy and chemistry, but it remains static in mathematics and theoretical physics. So it's about, 10%, less than 10% in mathematics and theoretical physics. And this is something we have seen actually, that in the more theoretical fields, there's still a really very high problem, I would say, with a number of women who are able to go through and get to the top journals, for example, and to get to the top of everything, actually. Thank you. Next one. Okay, so database of good practices. So it's worldwide. So there are different ways to collect these good practices. Engage families and communities in promoting STEM careers to girls, and engage females in exploring socio-scientific issues, promote social support for females, such as peer networks, mentoring by experienced STEM researchers, or develop female STEM leadership, advocacy, and communication skills. The question we have been wondering and posing is that, well, how efficient these good practices are. And it's very, very difficult to find that out, actually, because we all develop different sort of things for girls and women in science. And we see it now much more, with that UNESCO Day, February 11th, but it's very, very difficult to see what's really efficient. Thank you. Next one. Sorry. And you could, well, the drawings have been, what is a good practice? And this is a question. So drawings have been done by, we try to have the book attractive, and it was done by somebody called, I don't remember her first name, anyway, Castor, Leah Castor. And so then you have small drawings here of all the partners, all the members of the group. Next one, please. Okay, here are the recommendations. So you have different chapters, instructors and parents. So there's way more details in the book. And here are just a short sentence on each recommendation. For instructors and parents, avoid gender bias, promote gender balance and gender awareness. For scientific and educational organizations, promote a respectful collegial working environment, prevent, report, and address sexual harassment and discrimination, address impact of parenthood, promote child-friendly environments, and promote gender equality in institutional policies. And so this is really what we have been doing a lot already, but we try to put it together and with the ideas of everyone after this survey and this work on the publication and on the database. For scientific union and similar worldwide organization, and there needs to work on to change the culture and the norms to promote best practices, to increase the visibility of female scientists, especially for PICEs, editorial boards, to create committees for women in science. Next one, please. So gender gap in science, we have different, on the website, which is listed here, you have different materials. The summary of the project in 8 pages, currently in English, French, German, Spanish, as well as Chinese. And so these are extracts from the books, and it's something you can use to promote this work if you feel like it. And it's, I think it's a reference that you could look at least and find ideas. Next one, please. And here you have the links to the tools of the project. The list of all the survey questions. There were like 70 questions. It's a very, very, very complete survey, and interactive tools on the publication patterns. So you could get into it and you could see where you are personally, for example. And there's where are your friends, mathematicians friends, or astronomers, or yes, or physicists and so on. And the database of good practices, which is more or less in a final form. It's going to be very soon in its final form. Next one, please. Okay, I'm going to talk about the survey of mathematicians. So the survey has been done together, just 2018. And so the idea was to study the data for mathematics and applied mathematics, and for Africa, all science. So we offer an internship to a master's student in France, in Paris, and we worked with her. That was part of our project. We work on the data. So I'm going to present some findings, which are more details than what you could find in the book. And so the next one, please. Okay, a few words about the methodology. So we need to protect the anonymity of the respondents to the questionnaire. So in countries where there are a lot of people answered for a lot of respondents from those countries, it was fairly easy, but there are places you could say, okay, well, there's an answer here. You could just list to say who she is, even if you don't have the name, or who he is. So some data were not available for that reason, because we need to protect the anonymity of the respondents. So we had to analyze aggregated data by a team which is approved by the project. It means that you could go to the people responsible for the project and you could say, well, I want to study, I don't know what, this kind of data, and then you have to be approved. We don't want to give access to the data to anybody, and we have to have a sound scientific project. That person has to be, or that team has to have a sound project. And we have to use the air clock software. So we learn how to use it. The next one, please. Methodology. So we had a full-time work for a student during 6 months, March to August 21. The student was based in Paris. There was a daily follow-up by Professor Sophie Dabo, who is a professor of statistics, and she's based in Lille. And we had a weekly and hour meeting of our working group of 6 people. So the internship is part of the student master diploma. There will be 2 papers, one in applied maths and applied math, one in Africa, and the authors will be the member of the working group. And there are other studies which are in progress: astronomy, chemistry, physics. This is worldwide. And Latin America, it's just all disciplines, but for a big region. Next one, please. Also, I'm going to talk about the specific study of the survey for mathematicians, and among them, applied mathematicians. So an example of a question: when did you choose your primary field of research? And there are way more. So I'm going back to the numbers. 30,000 people answered. Okay, because there were so many questions, not everyone answered all the questions, but we made sure to take some, the question where enough people would have answered. And so it was, I said earlier, 32,000. So when the people started, and 30,000 were considered. And among them, 50% of women, 50% of men. So you could see already that doesn't really represent well the population of scientists. And in mathematics, we had 5,600, 47 female, and the mathematics, the population is 19% of the general population. And applied math, it's 2,150 people, 53.5% female, and it's 7% of the general population. So actually in mathematics, we were pretty good at spreading the survey, which was not necessarily the case in other disciplines. Next one, please. So I'm just going to go over a few questions. Who most encouraged you? This is a question with a multiple choice. So you could say that teachers, professors, mentors encourage you, your spouse and your partner, your parents, and so it doesn't come up at the end of all the numbers. If you add them, it's not 100%, it's way more, because you could choose different category and answers as you wish. And there's one category, it's your own determination, willpower, and hard work. And other students, other family members, parents, and so on. The next one, please. So I'm just going to give a few views. I'm not sure you can see it, actually. Who most encourage you? Teachers, professors, mentors. So the women are always in what I call green, and the men in orange. And so you could see the small difference. So I put the number 2. So you could see that who most encourage you. So 45% of the population, the general population, said that teachers, professors, or mentors encourage you. For maths, it's 50%, 52%, and for applied maths, it's 50%. And you could see the numbers. And you could see the small difference between men and women. Some difference, but not that much. So next one, please. So who must encourage you? Neighborhood, community, or friends. So you could see the numbers are much smaller. The proportions are higher for women, way higher, but the numbers are much smaller. So,
smaller for women. What are you saying? Smaller for women.
Smaller for women. I'm sorry. Yeah, I'm sorry. Yes. Thank you, Marie-Françoise. So, thank you. So, I don't know if you can see the numbers. It's okay. The next one, please. So there were questions about doctoral studies. I mean, some people stopped at the master degree. Some did have a doctoral degree. So we asked if you had a male or female advisor. So you could see the general population, the math population, the applied math population. So, and you could see that, well, there's the numbers. I put the numbers of the female advisors, and there's a little bit of difference between men and women. So there aren't that many female advisors, 15% for the general population. And in maths, it's not very surprising, it's 10%. And in applied maths, it's a little bit more, 12%. But the numbers are kind of small, so it's hard to do anything with these numbers, I think, for the general population of mathematicians or applied mathematicians. The next one, please. And so there were a number of questions about rating your overall experience in your doctoral program and to rate your doctoral, well, first about the program and then about the experience. So the program was, for example, program curriculum, quality of program, relationship with advisor and supervisor, the fact that the program treated everyone fairly, and the doctoral experience was, for example, did other students respectful of everyone? Did you get some support from advisor or supervisor? So the next one. So relationship with your advisor or supervisor. Okay, so so excellent is the light color, and no, it's a excellent, yeah, and poor is a darker color. So I want to mention that we studied the samples we had, and we did a statistical study, and we could see high statistical difference between female and male in general population, in the math population, and in the applied mathematic population. And we could do it, we studied too between female and female and male in a general population. You compare what was the general population and the mathematical population. So we compare female in both population and male in both population. And then you could see the high statistical difference in those, and then the less difference in for the other kind of populations. Next one, please. So did you get support from your advisor or supervisor? So you could see there are small differences. Statistically, it was medium statistical difference. So there are three choices. three options. Could be neutral, or it could be you could disagree, or you could agree. If you support, whether you support, whether your advisor supports you or not, supported you or not. So it's when people answered neutral, so there's some difference, medium, between female and male in math, and between female and female in general and math. And in the disagreeing, so did your advisor support you or not? There's a medium statistical difference between female, male in general population and male, male in the math and applied mathematics. When you do the comparison between math and applied mathematics, male thought that, well, there was a big difference in math and applied math. A fairly big difference. Okay, so next one. So there was a whole study about sexual harassment. Have you ever encountered it at school or at work? These were multiple choice questions too. And you could say, well, you had to answer, yes, it happened to me, or I witnessed it happening to someone else, or I've heard it happen to someone else, or I have not encountered it. And the question was asked to women and men. And okay, so I'm going to show just two graphs. Sexual harassment, yes, it happened to me. So for the general population, 4,000 people answered, yes, it happened to me. This is 14%. And for math and for applied math, it's fairly consistent. It's for 14.5 for math, and applied math is 13%. But you could see here the numbers are fairly small, but you could see there's a big difference for women and men, between men and men.
I think there is something wrong, because obviously the proportion for general is bigger than for math. So I think this number 14% is not correct.
Well, maybe so. I don't know.
But look.
Yeah, okay, you're right.
That this one is bigger than the second one, so the proportion must be bigger.
Yeah, okay. Well,
okay. There's probably a typo. Okay.
Okay, thank you. Next one, please. Well, I have the same, you're going to say the same defects again here. But general, it's 56%, math 60%, applied math 64%, not encountered sexual harassment. So a huge number of people didn't encounter sexual harassment at all. So it means haven't seen it, haven't been said about it, or haven't been themselves as sexually harassed. And well, you could see that men have seen it less, a little more. Men are more than women, actually. They answered they didn't encounter sexual harassment more than women. That's right. Okay, so next one, please. So to conclude, I would like to say maybe that's a confirmation that the gender gap science book conclusions, there's existence of a strong gender gap also in math. And in several cases, the situation is better in applied math than in math, which is also in line with the general conclusion. When the more experimental, the less theoretical the discipline is, the problem seem to be a little bit less. And there are many data available. So there's a lot of work you could do with those data, hundreds of pages with tables and pictures, and work is in progress to write the paper about the situation for mathematics and applied mathematics. The next one. Am I finished or not? Okay, thank you very much for your attention. So the cartoons have been made by Léa Castor, who is French. And I would like to thank all the members of the project Mark Cesar, Mehung Chu, Marlene Gous, Catherine Jamy, that you just heard, Elena Mialgeric, Marie-Françoise, Susan White, and to the member of the male mathematics applied math study, Sophie Dabo, Maria Esteban, Cecilia Rivera Martinez, and Marie-Françoise. Thanks a lot. Okay.
Thank you, Colette. So it was, say, maybe a little short, but we are on time. That's very good. So I think we would like to have now a discussion. So there is a chat which is in the YouTube channel, and if possible, we would like to know if there are questions in the chat. Okay, so first thing, we received greetings from all around the world, from USA, Oman, South Korea, Norway, Brazil, Cameroon, Italy, Kazakhstan, Denmark, Montenegro, Saudi Arabia, Spain, Ecuador, Mongolia, Peru, Austria, Japan, Kyrgyzstan, Scotland, India, Croatia, Nigeria, Nepal, Bangladesh, Cambodia, Ghana, North Macedonia, and Indonesia. So it's really a global event. I'm really happy to read the names of all these countries. So thanks, many thanks for the greetings. And in fact, it seems that there are about maybe 140 people who are following the YouTube channel. And we had 420 or more registered people, but of course it means that they are going maybe to watch the YouTube later, because it's not always possible to be free for 2 hours. But okay, in any case, that was the congratulations, that the greetings, very good. And at that point, there are no questions. So, okay, so I would like to ask if also congratulations to the whole team who analyzed the data, not only to us here. So that's very good. We were going to tell them, thank you. And okay, so is there anyone among the panelists who would like to say something, to ask questions to Colette? Yeah, Cathy? So, yes.
Thanks for your talk. Maybe you could say something about why and how this project got started. Seems like a very large project. Could you say more about who had the idea to have it?
Yes, I think maybe Marie-Françoise, do you think you can answer that question? Because I was not at the start of the project.
Okay.
I entered the project later, you know,
yes,
on it.
right.
Third year.
Yes, I can answer the question, yes. Okay. So in fact, what happened is that there was already a study. There were already, in fact, 2 different studies. One was made by the physicists. This kind of survey of scientists had been done twice already by physicists. And on the other hand, for the analysis of publication pattern and so on, there was a study already done by Elena, who was mentioned, and Lucia, who's in fact also helping us with a webinar today. And then there was this call by this International Science Council. They wanted to receive multidisciplinary projects of scientific unions working together. And so there were some contacts taken through the, say, International Mathematical Union Committee for Women in Mathematics, and also, for example, some physicists I knew through friends in Argentina and so on. So at some point there was a group who just presented a project, and we had this idea of having these 3 different types of things, so extending what the physicists did to other disciplines, and extending what was done in mathematics for the publication in other disciplines, and also having this idea of a database. So we got a grant, we got money, and we were able to pay people for doing the study. Of course, there was a lot of say, scientific work that was done by ourselves. We were not paid for that, but we had money, we made it possible to do this study. So it was really exciting. We started like with 3 unions, and then we were 7, and then 11. And now we have this standing committee for gender equality in science, which is also a follow-up of the project. And now we have 19 unions, and so it's really growing. So that's what I want to say. And I see a lot of questions now coming in the chat. So let me, okay. Okay. Yes, well, okay. So it's a question which is not particularly for Colette, but maybe we answer it too. I wanted, so someone called Michael, I wanted to ask about the IMU Committee for Women in Mathematics recent message celebrating 20% representation among ICIAM speakers. Okay, so in fact, indeed, we've been happy to mention that we have now 20% speakers at ICM, because if you look, for example, at numbers we see here in Colette's slides for top journals, even now in mathematics, we have around less than 10%, you know, we have this situation here, that the proportion of women publishing in top journals remains very low, even though the proportion of women writing mathematics has raised from, say, 10% to 27% in the period. So we've been also looking with Elena to the proportion at ICM. And at ICM, it was very low for decades, and then it started to grow slowly, and then it reached something like 15%, and it was staying 15% like for 15 years. And this year, the committee has been very active in trying to have more women lecturers at ICM, and we are reaching 20%. And so the idea was to mention when there is some progress, even though, of course, 20% is, well, 20% is not that different from the proportion of women publishing in mathematics, which is 27%. So having 20% of ICM speakers is, say, not too bad compared to the situation in top journals. So it means there was really some effort, and we wanted to mention it, to acknowledge it. Yes.
There has been,
of course, I mean, many people say that would strike one as a disappointing percentage, but how should we understand it in the context? Well, the context is that it was much less before, and that's why we prefer to notice when there is even a slight progress. Okay, is it?
Okay, maybe I can answer a few of the questions. So in the order, from Diogo, are we seeing changes in time concerning gender equality? Is it always evolving positively? I mean,
yes, exactly. I'm taking one question after the other, Colette. So it was the next one. Okay, you can answer if you like.
Okay, or it can go backwards as well. So what I could answer from this study, it was a static study, so it's impossible to say if it was better or not. But you could see, except for the, I mean, for the survey, it's static. But for the publications, you could see there's an evolution, really, which is a somewhat positive evolution, I would say. So what's that's about? And it's true, we know that things are going backwards sometimes, you know, but we have to somehow make the study to affirm it is true or not. And it really depends very much on the place, it depends very much on the discipline, it depends. So with publication studies, the study of the publication, we could see a positive evolution, really. So this is something good about that.
Okay, maybe I can say something also, because we've been studying the ICM speakers even before 1970. Mm-hmm. And you can see that in the 30s, there were women talking at ICMs. And then after World War II, it became nearly zero. So there was really a regression, which is related to this fascist period in Italy and Nazi in Germany, and also the evolution of society after World War II, where women were more encouraged to stay at home and take care of their kids and things like that. So that's the real kind of social experience that happened, that the proportion of female talking at ICIAM became smaller in the 50s than it used to be in the 30s. So it happens. We can go back, no problem. It happened already. Okay, so, okay. Colette, you see the next question? So about higher education.
Yes. Yes. The question is, does your research focus on higher education? How can we track data on gender gap in STEM in secondary education, especially in Africa? So as I said, so survey was done through a snowball process. So it means that we researchers in math or professors in math or students in math would spread it among our friends, and the friends would spread it among their friends, and so on. So we could not really reach secondary education, and in particular in Africa, there were some questions about the secondary education to start in the beginning of the survey, but we could not reach all this population. I think there has been work done by UNESCO on that population, and some data of that population. And I think there's even been a very recent study, in what was going on for girls in particular during this COVID period, which is really very pretty bad for everyone, and especially for girls in Africa or other parts of the world.
Yes. So,
what I would say.
So maybe I can add something, because I know that in Africa there are several organizations for women in mathematics, like in Cameroon, for example, and in Kenya, and they do have specific actions towards secondary school girls. But we didn't study it in that project.
No.
Okay, so more questions?
Yeah, there are more.
Do you see them? Like suggestions to improve the culture of a department?
Yes, okay. Well, there are a lot of suggestions in the book, and then we have to somehow to get together, and we can just answer a question. I think it's really to have a general, it's really a lot of, establish a mentoring program, and establish, to do in a way that's a non-sexist environment, because I can see myself that some departments, it's a very sexist environment. So it just should not happen. It has to be forbidden, totally forbidden. And so there are things to do, a lot of things to do. And we have suggestions in the book. So we can help if you want about that matter. Was it good enough, my answer?
Yes, and now there is a question also for this famous women's productivity, the productivity gap. Can you explain how was that
no, I
evaluated?
I cannot explain how it was produced.
Okay, I can.
You can, go ahead.
I can. So, okay, so it's just a matter of measuring the number of publications over time for someone who's identified in the database as male and someone identified in the database as female. So in the past, female, say they publish, say, one paper at the beginning of their PhD, and then a few years later, they appear as publishing less than men. So it's in terms of the number of publications over time. And what was noticed is that this So that's the productivity gap, meaning that women tend to be less productive than men because they they are busy with other duties and occupations. And the observation is that it is diminishing over time, so that this gap is getting smaller and smaller. So it can be also identified as a progress towards equality. Okay, so I see.
I could take the next question, which is,
Yes, okay.
what suggestions do you have for helping find female mentors or role models for young women to encourage them to consider math fields? And how can we most effectively showcase women who are in the field without overwhelming them with such requests? So my first answer would be, first, you have to look for the women. And you really have to look. If you don't really look for the women, you'll find just a few of them. You just find 3 or 4, and they'll be totally overwhelmed by everything they have to do, which is not right. So you really have to look for the women, not only the women next to you, but really look for them, and you'll find them. And this is my experience as a mathematician, a women mathematician in my department, and in where we this recruiting committees, you could see where people look for women, they find them. And you really have to look for them. And there are plenty of them. And it's the same for men. And, it's just that the networks of men are more established, have been more established for years and years. So it's much easier to find men, but look for women, you'll find them. And all sorts of women. Not necessarily they could be in academics, they could be in private companies, they could be, in agricultural, bureau, state bureau and so on. You'll find them. There are plenty of them, really. And it's true that if you're looking for, that's what I like to say, if you're looking for a woman who has blue eyes and dark hair and so on, she just works in a tiny, in something like you want her in a discipline, a very, very restricted discipline, you won't find her, but you have to look for them, you'll find them. I'm really positive about that.
Okay, so maybe we take the 2 last questions we have already, and then for reason of time, we need to switch to the other panel because we really need to finish the session at 6 p.m. CET. So there are 2 more questions. One from Budi. If there is a sexual harassment, usually it's very hard for students to report the problem, to open the problem. What should we do to help them in study and daily life?
Okay, so I can talk about what's going on in France. It has been made compulsory by the state to have places where students and faculty and staff could speak up and say, there is a problem here. I've got through a problem, and it could be. It's been really compulsory to have it in France. So it doesn't mean that everybody who has a problem is going to go there, but at least we can, you can advertise that place. You can have posters. You can talk about students about that. When they start school, every year we have the students when they start the first year, the second year, third years. We have meeting with the students. We can tell them it exists, and has to be posted everywhere. And this should be more open. The place should be more open to this kind of problems because we know the problem exists. It has been going on for years and years. So we should advertise, and we should have the institution do something about that. It can't be done just by individual. It has to be done institutionally. We have to change the system. And
so there is still.
Pardon? Sorry, I'm sorry.
Yes. Okay. So there are 2. Well, one question and a comment. So the question is, how can we inculcate a paradigm shift for women to prepare for mathematics content?
I don't understand the question myself.
Mm-hmm.
I don't understand the question.
You don't understand the question. So I think what is suggested here that women sometimes don't like to study mathematics, or they don't choose mathematical topics, and we would like to change this state of mind.
Mhm.
So I don't know if you have.
Well, we just have to try to, well, I don't know. We are going to class, to, you know, to high school classes, and to try to say that it's possible for women, for girls to study math. And it's true, it's like end work, because we can't go to every class, but this is what we're trying to do. And well, I mean, there are structural, because what's going on in France right now is the math is not compulsory in the last 2 years of high school. So it means that a lot of girls are dropping out from math, which is kind of a problem for the future. So this is a systemic problem. And yeah, I know there's a problem.
Yeah. Okay, so just maybe to conclude this part, there was a discussion going on for my answer about the productivity gap, and someone saying I would argue that there are many other ways besides publishing that make mathematicians productive, which of course I totally agree with. But then there is an answer by Elena, who's with us today. So hi, Elena. And who did this study, and she's also answering in the chat. Regarding productivity, yes, we fully agree this metric is, but in fact we fully agree. So, but this metric is considered in a critical way in the report because it's utilized frequently by departments, which is why we looked at it too. So that's the way people evaluate also the productivity of a person, by looking at its at the publication record of this person. So it's not particularly because the project agrees that this is the only way to be productive, but it's because really it's the way the departments are evaluating the career, and looking at the progress in career is very much based on publications. So that's the reason why, and it's also something that is kind of possible to measure. So that's also why we study it. So that's what is meant by this productivity gap. Okay, so I'm really very happy with all this chat and questions. It really covered many aspects of the talk of Colette. And if I think Carol agrees with me that it's now time to switch to the second part of the meeting. So Carol, I let you now take the hand for the second part, for the second hour. Okay, many thanks to everybody, and thanks for listening and being with us. Thank you.
All right, thank you. So my name is Carol Woodward, and I'm from Lawrence Livermore National Laboratory in California in the United States. And I'm going to be moderating a panel today with 3 current and former presidents of the Association for Women in Mathematics, or AWM. I want to do a brief introduction of our 3 panelists today, and then we'll start with each one giving a brief talk on some of the experiences they had and the environment in which they were operating the Association for Women in Mathematics while they were president. And then we'll take some questions and answers after that. So our first panelist today is Dr. Linda Rothschild. She served as president of the Association for Women in Mathematics from 1983 to 1985. She received her PhD in mathematics from the Massachusetts Institute of Technology, and she held positions at Tufts University, Columbia University, and the Institute for Advanced Study, and Princeton University before moving to the University of Wisconsin-Madison, where she was later promoted to full professor, and where she remained. Oh, and then she moved to University of California at San Diego as professor of mathematics, where she remained until she retired in 2011. Dr. Rothschild has worked in the areas of Lie groups, partial differential equations, and harmonic analysis, and the analytic and geometric aspects of several complex variables. She's published over 80 papers in these areas. In 2003, she won the Stefan Bergman Prize from the American Mathematical Society. In addition to her service for AWM, Dr. Rothschild served as vice president of the American Mathematical Society from 1985 to 87, She presented the 1997 Emmy Noether Lecture for the AWM, or the Association for Women in Math. In 2005, Dr. Rothschild was elected a Fellow of the American Academy of Arts and Sciences, and in 2006, she was an invited speaker at the International Congress of Mathematicians in Madrid. The conference, Complex Analysis 2008, was held at the University of Freiburg in Switzerland in honor of Linda Rothschild for her influential contributions to the subject of several complex variables and connections to partial differential equations in geometry. A particular aim of the conference was to encourage female students to pursue an academic career in mathematics, a goal Rothschild has helped to foster by establishing a scholarship for unusually talented junior high school girls to accelerate their mathematical training by participating in a summer program. Our second speaker is Dr. Kathy Kessel. Dr. Kessel served as president of the Association for Women in Mathematics from 2007 to 2009. Dr. Kessel received her PhD in mathematics from the University of Colorado Boulder, specializing in mathematical logic. She taught for a total of 18 years as graduate and postgraduate until the 1990s when she made a switch to research and education. Dr. Kessel is a mathematics education consultant, now based in Berkeley, California. She has taught mathematics at various colleges and universities and has worked as a researcher in mathematics education at the University of California and the University of Melbourne. Dr. Kessel edited Lipping Ma's Knowing and Teaching Elementary Mathematics, was an additional writer on the National Council of Teachers of Mathematics Principles and Standards for School Mathematics, and was the lead editor for the CBMS report, The Mathematical Education of Teachers. Her publications include articles in the MER newsletter, the AWM newsletter, Research in Collegiate Mathematics Education, and the Encyclopedia of Gender. Dr. Kessel is the winner of the Association for Women in Mathematics Louise Hay Award and a blogger on mathematics and education. She worked as a mathematical education consultant until 2015. Our third speaker is Dr. Catherine Leonard. She is president of the Association for Women in Mathematics, starting in 2021 to now. Dr. Leonard received her PhD from the Department of Mathematics at Brown University. She went on to positions at the California Institute of Technology, California State University, and is now a full professor in the Department of Computer Science at Occidental College in California. Dr. Leonard received a Henry L. Alder Award for teaching from the Mathematical Association of America in 2012, and she received the AWM Service Award in 2015. She served as the AWM Meetings Coordinator from 2015 to 2018 and is also director of the NSF-funded Center for Undergraduate Research in Mathematics. Dr. Leonard's research focuses on geometric modeling with applications to computer vision, computer graphics, and data science, and she's received multiple major grants, including a National Science Foundation Career Award. So I want to thank our three speakers for joining us today. We will first hear from Dr. Rothschild, who was, as I mentioned, president of AWM from 1983 to 1985.
First, I would like to thank Carol and Marie-Francoise for their work in organizing this symposium and for inviting me to participate. In this discussion of AWM, the Association for Women in Mathematics, I would like to devote my time to the early history and prehistory of this organization and give some context to its origins. The first rumblings of the need for an organization supporting women in the profession of mathematics in the US began in the turmoil of the 1960s, coinciding with the women's movement, the anti-war protests, as well as the fight for racial justice. In that decade of the modern era, women's lives were still limited in all areas, including education. At the elementary school level, girls had classes in cooking and sewing while boys learned to work with tools and do carpentry. At the high school level, girls were offered separate but unequal opportunities. For example, in Philadelphia, the city in which I was raised, the most prestigious and best funded public high school admitted only boys. At the level of higher education, many of the Ivy League universities, such as Yale and Princeton, were completely closed to women students, while others, such as Harvard and Columbia, admitted women in smaller numbers and in separate colleges. The number of male college graduates greatly exceeded that of females in the US. Career opportunities for women even college graduates, were limited. All of this has changed, at least to some extent. In America, women now outnumber men as undergraduates in universities, but we are not nearly done. Although women comprised a fair proportion of mathematics majors in the 1960s, most intended to become teachers, and there was little encouragement for them to pursue graduate study in mathematics. In fact, the PhD program in mathematics at Princeton University, arguably the top program in the US at that time, did not admit women at all. I still have a formal rejection letter from Princeton in 1965 stating their policy. Very few women had permanent positions as faculty members in mathematics departments, and many of the top graduate programs had no women at all on their faculties. Several steps in the pipeline led to this result. Few women were admitted to PhD programs in math. Some of those who started did not finish their degrees, which justified admitting few women students. And the old boy network meant that the female students were rarely recommended to academic positions. To make matters worse, many universities had anti-nepotism policies, meaning that a married couple could not be employed in the same department or in some instances at the same university. Women often had to choose between having a partner and having an academic career in mathematics. Bearing children was regarded as a sign of not taking one's career seriously. Inspired by the social movements of the 1960s and early 70s, groups of women mathematicians seeking action formed around universities in the US, in particular in the Berkeley area on the West Coast and the Boston region on the East Coast. AWM was founded during the 1971 annual meeting of the American Mathematical Society, AMS, with the energetic mathematician Mary Gray as the first leader of the organization. Of the first 6 presidents of AWM, 3 had been active in Berkeley during the 60s and early 70s, including Mary, while the other 3, myself included, had been part of a group meeting in person in Boston during that time. Alice Schaefer from our Boston group became the 2nd president and grounded the organization by establishing a physical office with staff for AWM at Wellesley College near Boston. Although Alice was older by many years than most of the rest of us, in her quiet but persistent manner, she was a driving force in keeping AWM moving forward for several decades. I apologize here for not mentioning names of the other women who were instrumental in AWM's early years, but I want to go on with the rest of the story. In the 1960s, it was relatively easy for a new PhD from a good university to find a position in a math department in the US, unless the applicant was female. In contrast, in the decade of the 1970s, the academic job market dried up, and many men felt that hiring a woman would be taking a job away from a man who really needed it. AWM generated much activity in the 1970s, its first decade. Early achievements included the publication of a newsletter and the sponsoring of meetings and receptions at AMS annual and regional meetings. At last, women attending mathematics meetings could find each other and have a home away from home. AWM established a written set of bylaws, formally incorporated in the state of Massachusetts, and was granted tax-exempt status. The organization gained recognition as an affiliate member of the Mathematics Consortium, Conference Board of the Mathematical Sciences, CBMS. At national mathematics meetings, AWM held panels in topics of special interest to women, but also attended by men. The organization also supported some political issues, including the proposed National Equal Rights Amendment, ERA. AWM supported some lawsuits brought by other women's groups against discriminatory practices, including one targeting the National Institutes of Health. Nevertheless, through the 1970s, AWM remained small in membership numbers, and the organization was not universally respected by prominent male mathematicians. One of the main reasons women in mathematics needed to create an organization outside the AMS was the lack of women in AMS leadership. The male AMS leadership regarded itself as an elite clique of mathematicians from top research universities, while members of the fledgling AWM leadership were not regarded as major figures in the research community. By the early 1980s, about 20% of mathematics PhDs were being earned by women, up from about 6.5% in the 1960s. Hiring in mathematics had recovered, and women were beginning to obtain permanent positions at many universities, though not in proportion to their numbers. Some leading mathematics departments had still failed to hire any women at all, perhaps hoping that the problem would go away. Women still had difficulty being taken seriously as mathematicians. Maternity leave or paternal leave did not yet exist, and those of us who had young children sometimes had to pretend our teaching or research lives were not affected by pregnancies or family responsibilities. Some female mathematicians even felt that joining AWM might endanger their future careers or make them appear to be less serious about research. For example, a young woman holding a tenured professorship in a top-rated math department turned down an invitation to give a major AWM address, saying that she wanted to be chosen for her research, not for being a woman. It has not happened again. As the number of female mathematicians in the research universities grew throughout the 1980s, AWM recruitment drives were successful in greatly increasing the size and prominence of the organization. Furthermore, women were now also becoming leaders in AMS also. In 1983, the distinguished logician, Julia Robinson, who had long been denied a professorship because of nepotism rules, became the first female president of the AMS. Although all the presence of AWM through the 1970s and 1980s came from academia, with backgrounds in pure mathematics. Since AWM at this point was being criticized for being too focused on academia and research in pure mathematics, it was time to expand its outreach to applied mathematicians, including members working in industry or government, and to mathematicians who devoted their efforts mainly to teaching at the college level or working to improve the teaching of mathematics to children. Later AWM presidents and officers have worked to make AWM into the much more inclusive organization it is today. In some of the other sciences, women have organized themselves only as a committee of an umbrella organization. However, perhaps because of its independence, AWM has been able to help women more in mathematics, such as by sponsoring conferences in which all the speakers are women. As an organization, not just the committee, AWM gives opportunities for women to speak out and to take more leadership roles. The proportion of women among new PhDs in math in America has increased to about 30% in the present, but this number has not grown in the past 15 years or so. We need to understand this lack of growth in the context of other opportunities that have opened to women in the last few decades. Young female scientists are now achieving prominence in other scientific fields, such as biology, chemistry, computer science, and astrophysics, for example. Women mathematicians may not achieve equality in numbers with men, but perhaps this should not be a major goal of AWM. There's still many barriers to equal opportunities for women in mathematics in the US. AWM can continue to encourage girls to become mathematicians and to make it possible for them to have full lives and successful careers. Thank you.
All right, thank you, Linda. We're going to go ahead and hear from each of our panelists before we start taking questions, but you are welcome to continue to you're welcome to add some questions to the live stream chat as we go. Okay, our next speaker is Dr. Kathy Kessel.
Okay, I think Maurice Francoise is going to put up my slides.
Yes, in fact, yes. Okay, 1 second.
Okay, so as you'll see on the slide, I was president between 2007 and 2009, and I'm going to talk about an event of 2005. So I'm calling this talk.
Do you see it fine? Do you see that your slides? Okay.
Good to me.
Yes, we see the slides just fine.
Okay.
Go ahead, Kathy.
So I'm going to talk about an event of 2005. Hold on, back up, please. I'm going to talk about an event of 2005. And so you'll notice that's 2 years before I became president. And then please go on. I'm going to talk about an event of 2005, go backwards to a similar event in the 1980s, talk about the response from AWM and others, and then return to 2005, just before I became president, and continue on to the present day. So what was that event in 2005? Next slide. Some of you will remember this. Lawrence Summers, president of Harvard University, one of our very prestigious US universities, remarked on the lack of women on mathematics and science faculties, saying, as a suggested explanation, there are issues of intrinsic aptitude, suggesting that women were less capable of being top mathematicians. This resulted in a lot of publicity and some headlines like, was Summers right about intrinsic aptitude in major newspapers such as the Washington Post? Well, this wasn't the first time an event like this had happened. Next slide. In the 1980s, there were these things called talent searches. They still exist. To identify talented students, a university mathematics entrance exam was given to 7th and 8th grade students by some psychologists. And they were interested to find that a very large proportion of students with high scores were boys. And they interpreted this as saying that boys had superior ability. This large proportion was not due to taking different mathematics courses in school. There were many people who disagreed with this conclusion, but it was published in Science magazine, a very prestigious journal, and resulted in, like the Summers event, a lot of publicity. Next slide. And here are some of the headlines from the 1980s. Do males have a math gene? Are girls born with less ability? And a study from the 1980s, conducted by some psychologists, found that such publicity can have an adverse effect on girls and their parents. It's a very interesting study. So girls who heard of the talent search study took fewer mathematics courses and were less confident mathematically. Well, so next slide. What was AWM's response? There was an editorial in Science magazine responding to this article about the talent search and it was written by the two first AWM presidents, Mary Gray and Alice Schaefer. There was an AWM statement about the article, and the flaws in the article and its methods. There was a press conference organized by the American Mathematical Society, and there were articles in the AWM newsletter. But unfortunately, there was a similar article was published, next slide, in 1983, 2 years later, and it was followed by similar headlines. Okay, now we're going to return to what happened in 2005. Responses were more extensive than those in the 1980s. AWM was a much older organization. Next slide. And AWM's members helped to organize statements in support of women from other mathematical societies, including the American Mathematical Society and the International Council for Industrial and Applied Mathematics, ICIAM. And the AWM president of that time sent a letter to the New York Times, and that letter was published. We were very, very pleased about that. You could send a letter, but it doesn't always get published. And AWM members wrote editorials in newspapers and wrote letters to the editor of newspapers. And further, next slide, is the president of the time remarked, much good actually came out of Summers' remarks, because as the anger it produced resulted in greater public focus on barriers facing women. And some of that focus occurred in a workshop at the Math Institute, Burrs in Canada. And that workshop resulted in a report with recommendations for recruiting and retaining women in mathematics departments, and a different type of greater public focus came out in a play called Truth Values, created by a woman who had been a student at MIT in mathematics, and that was performed at the joint mathematics meetings and many other places after that. Next slide. And as president, I had the opportunity to discuss the evidence mentioned by Summers in the AWM newsletter, but also in other venues such as the newsletters and talks of other mathematics societies. And so this evidence was actually rather thin, and it turned out to be a main piece of it was the talent search study from the 1980s. And fortunately, next slide, some of this evidence has been countered in a very substantive way by an article written by AWM member Janet Mertz together with a psychologist. And it's a very interesting article using international statistics, some from the IMO, the International Mathematics Olympiad. Next slide. But I talked about policy and reports and things for adults. What about students? Well, AWM is a many-splendored thing. Next slide. And we have programs for students too, trying to get at some of these issues. I think that there was a question about encouraging girls earlier. This is one of the ways in which AWM does it. We have an essay contest for students of any gender in any country, and there's the URL. This essay contest began 20 years ago. Each student interviews a woman working in a mathematical field and writes an essay. Students who can't find a woman to interview are able to request someone to interview and that's names are supplied by our essay contest committee, which has grown quite large, I think. And I'm going to end this talk with some examples of reactions of students to their interviewing. So the essay contest can have a profound effect on students. One student interviewed a queer woman working in STEM called Liz. This interview had a significant impact on the student Jessica. She wrote, you can read what she wrote. It had a huge impact on her. It had a huge impact on her sense of self. It's only looking back now that she realizes that how much of a trailblazer Liz was and how much of an eye-opening turning point it was for me in the development of my own identity. Another student commented that female mathematicians were godlike people, but also just people and not so different from her. And finally, next slide. A judge of the AWM essay contest observes that students get to learn not only about math and its various forms, but also about the journeys that mathematicians take. Quite often you'll read an essay about someone who changed direction either from within mathematics or from another discipline into mathematics based on an experience they had with a teacher, class, to project, etc. The contest brings those stories to light. And so these quotations come from an article called Telling Our Stories, which is written by the two people who run the essay contest during its 20 years of existence. And this article will appear in a volume created in honor of AWM's 50th anniversary, which has a wide variety of articles and contributors. And I look forward to your questions at the end of this panel. Thank you for your attention.
All right. Thank you, Kathy. Very interesting remarks. And our third panelist is Dr. Catherine Leonard, and she is our current president of the Association for Women in Mathematics. Catherine?
Hi, thanks so much. Thanks to all of you for organizing this and bringing so many people together from so many different places. So I thought I was asked to talk about the challenges that women in math are facing now and what the Association for Women in Math, AWM, is doing to address those challenges. But I thought I would start first by telling you a little bit of my own story in math. I think Linda did a really nice job of outlining what was happening in the math community at the time that she kind of came up. And I'm maybe the next generation from her. And so I feel like that might give a nice sense of progress though. Okay, so I was in the first class of women at the high school that I went to. They had been an all boys school up until the year that I was in 9th grade. And I can say that the faculty there were not really equipped to handle the sudden influx of women. I think they hadn't really thought it through completely, and maybe some of them were even a bit resentful that their school had changed suddenly in this way. So when I started high school, I was 3 years ahead of myself in math, but I was placed in the my age appropriate, grade appropriate math class again. So I had to retake material that I'd already taken. In school, I was good at English and math, and I was consistently advised to go into English. People were not talking to me about math at all. And so when I eventually ended up in college, that's what I did. I was an English major. So in my 3rd year as an English major, I petitioned the university to not have to take the math course requirement for graduation. So for those of you who are unfamiliar with the US system, unlike, say, the European system where you're sort of tracked early on in your college career to the area that you want to specialize in, and you don't have to take other kinds of classes. In the US, there's a strong influence on this kind of liberal arts education. And so students are required to take classes in history and sociology and science and math and art, regardless of whether or not that fits their interests. So I was an English major, and I was like, why are you making me take this math class? I'm not going to need it at all. So I petitioned not to have to say it, which now that I'm on the other side of this, I find really hilarious and rather bold. Of course, they said no. And so I found myself in a math class taught by a research mathematician for the first time in my life. And it blew my mind. Like, I had up to that point thought of math as a set of problem types, a set of algorithms to solve those problem types. It was pretty straightforward and not very interesting. But this professor showed that there are these structures that you were studying, and that the things that I had previously thought of as math were actually outcomes of those structures. So long story short, I was like, this is really great. Meanwhile, in my English classes, it felt like whoever shouted the loudest was sort of winning the discussion, and I was getting tired of that. And math seemed very clean. You'd either proved the thing or you hadn't proved the thing. There was no arguing about it. And so I added a second major in math, which I finished in a year and a half, which if you want to go to grad school, I do not recommend. But anyway, that's what I did. And I went on to graduate school. Then there were 2 women faculty out of maybe 15 in my graduate department, one of whom had sort of checked out of the department. And so the one who was remaining is Jill Pfeiffer, who was also a former president of Association for Women in Math. And she was kind of the sole person, while she was trying to maintain her own very prolific research career, she was like the sole person in the department that was kind of holding all the women together. So she really did an invaluable service, I think, to the women in the department at the time. From then, I went to a postdoc at Caltech. Caltech, I'll point out, is an institution that in my lifetime did not admit women students. And there I was the only woman with a PhD at the time. The other woman in the department was the department manager, which is an administrative role. And I spent a lot of time in her office. I would say that my postdoc was probably the most challenging part of my academic trajectory. So I tell this story because at the same time that there was still a lot of challenge for me, things were not smooth sailing. There were obstacles to overcome. There are still obstacles to overcome. It's in sharp contrast to the setting that Linda described. And so I think it's really important for us from time to time to stop and celebrate the successes that we've had and the progress that has been made, because otherwise it just feels like there's too much to do and we'll never get to it all. And that might be true as well, but progress does happen. And I think it's important to celebrate that. So so I was asked to talk about some challenges that women in math are facing now. And I'll start by talking about some challenges that AWM is really actively pushing on right now. And then I'll talk about some challenges that are on our minds, but are not like at the forefront of what our actions are following up on at the moment. So one major issue is that currently in the US anyway, people think that the problem of gender equity in math is solved. They look around at the graduate students, they see women. They look around at math faculties, they see women. They go to the massive conferences, they see women, they decide that it's fine. So every time that I staff the booth for the AWM organization, I have people coming up to me asking why we're still needed. I have people coming up to me telling me that we're a sexist organization against men, So I actually found myself in about an hour-long argument with someone where I tried to show all of the ways that women are still at a disadvantage in the math community. Another major challenge for an organization that's called the Association for Women in Math is to continue to be true to our mission of supporting women and girls in math, while also adapting to the currently rather quickly evolving idea of gender as not a binary, and working to recognize that other genders and gender minorities don't have their own organization, and that AWM is kind of uniquely positioned to help create similar opportunities and cultural shifts for them as well. Ensuring that an organization that was developed primarily by white women can serve the needs of all women. And so that's a big thing we've been working on in the past few years. There's the pandemic, which I think if you've read headlines at all, you've probably read that the pandemic actually helped men's research productivity while it hurt women's research productivity, and that women are experiencing far more burnout. The challenges of working from home with small children, where the toll was felt much more heavily by women, things like that. And then financial reliability, and this also of the organization. So this also really came out in the pandemic because much of our income stream comes from donations. It comes from registration at events that people are going to in person. It comes from memberships from organizations like universities who were also experiencing financial distress during the pandemic, and therefore were dropping their enrollments. Those are back up, but really we are an organization that has 1.75 paid staff members and 200 volunteers doing the work of the organization. Our volunteers were overwhelmed with work. They are these women who are disproportionately affected by the pandemic. And so just being able to, having to rely on volunteers to maintain the programs that we've been so successful in maintaining is, you know, the pandemic really showed us that that is not 100% sustainable in all circumstances. So to address those challenges, so in order to address the challenge of the problem is solved, there's nothing left to do, now we're just being sexist against men, we've continued to document the ways in which there's an equity gap, such as, well, so the report that Colette gave is really lovely, and I really look forward to that article. We will add it to our arsenal of resources for sure. For example, women in the top research institutions are in the very low, they're like around 10% of the top research institutions, whereas, you know, they're pushing like 40% in kind of the least desirable academic jobs, including like non-tenured track positions. They are only 6% of editorial boards at the top English language research journals. And in fact, there are some very well-regarded journals that have no women on their editorial staff. As was mentioned earlier, women in graduate school, the proportion of women in math graduate school was steadily increasing for some number of years. And then in the early 2010s, I guess, it's just kind of leveled out, and it actually looks like it might be starting to drop down again. So a way that we can regress, referring to the question that was asked earlier. And then just general visibility for women is part of this as well. So Colette was saying, if you want women, go look for them. They're out there. They certainly are, but they are hard to find. So the ways that we've been trying to address those equity gaps are, we recently launched a research journal for AWM called La Matematica, and it has a hugely diverse editorial board. 75% are women and about half are people of color. So this is like way off the charts compared to almost every other research journal. We've been expanding our student chapters and identifying funding to give them more support. The next generation is enthusiastic and they have a lot of energy, and being the generation after me, their experience is probably to mine what mine is to Linda's, and so they're probably less exhausted than we were when we got to where we are now. We've started a YouTube channel where we post any recordings of talks and panels that we've hosted, featuring women in math, talking about a wide range of things from research to life path to educational initiatives. And then on the research end, probably the most impactful program that we've launched in recent years was launched by Kristen Lauder, and it's Research Networks for Women. So we now have about 25 research networks for women. So a research network for women is a group of women who are all interested in a specific research area, like geometric topology or whatever your favorite research area is, and they organize a research collaboration workshop where women come together and work for a week in small groups on an open research problem, and then that collaboration is intended to continue beyond the length of the week. Preliminary results are published in a proceedings series that we have in collaboration with Springer. We have follow-on special sessions at big math meetings, and the NSF has given us a substantial amount of funding to support this. So as a result, each research network now has a web page with a long list of women who belong to it. So, and these women are not just in the US, the women are primarily US and Europe, but also more broadly distributed. So if you want to find a woman in geometric topology, you can go find the research network on AWM's page and get a long list of women in that area. So it's both helped women create positive research collaborations with other women. It's created networks of women. We heard before about men getting jobs in the 60s through their networks. And in fact, that continued after the sort of, there was kind of a phone call thing where a department needed to hire someone, so they called their friends and said, hey, I need someone in this area, who do you recommend? And then that person got hired, which is just, given what we go through now, is pretty astounding. Anyway, so now we have these networks of women who know each other. People who participate are at all ranges, from early graduate students all the way to senior mathematicians. And so we've created these communities of people at many different levels around a shared interest in a research topic. Well, my research network completely transformed my life, I can say. It's one of the biggest impacts that my professional life has had to date. To handle the evolving ideas about gender and the gender binary, we updated our mission statement to continue our emphasis on women and girls, but also express a desire to support other minoritized gender and gender identities. We've educated our executive committee on issues faced by trans women, and we've expanded our relationship with a US-based organization, Spectra, that's focused on LGBTQ+ issues. To help address the inequities, the racial inequities within AWM, we've widened solicitations for speakers and EC members. So we currently have more than half of our executive committee members who are not white. Our new president-elect will be the first Black president of AWM. We have an upcoming research symposium that's happening in June. And because of our broad solicitation for speakers, the racial diversity is the largest that it's ever been among the plenary speakers. We're working to expand our relationship with the National Association of Mathematicians, which is an organization designed to support Black mathematicians in the US. And then in 2018, we received a diversity task force study report that had surveyed our community, done interviews with many people one-on-one, and had compiled a set of recommendations to AWM for how it could for work that it should do to improve itself along those issues. And our work on that got a little disrupted by the pandemic, but we're back on track, and hopefully in the next 6 months or so, we'll be able to say, here's our first sort of foray into addressing these issues and how we plan to address them. And I see that I've been blathering on for too long. I have more to say, but I'm sure it'll come up in the questions, and so I'll stop there. Thanks.
Great, thank you, Catherine. It was very interesting and really nice to hear all of the new things that AWM has been, well, the challenges, but also the different strategies to try to address many of them. Okay, so I wanted to open it up to questions from the audience. I have a few ready to go on my end if we don't have anything yet from the audience. I'm thinking, I'm not seeing anything yet. So let me pose a question.
So Carolina is saying that there were many thanks in the YouTube for the presentations.
Yes,
So
I saw that.
thanks for the panelists, but questions are coming, but you should go with your own questions at that point.
Yes, so we have an audience from around the world this morning, or evening, or whatever it is for folks. And there are many different challenges that are present in all the different cultures that we see worldwide. I want to ask, what advice would you give someone from another country who wants to start an organization to advocate for women in mathematics? So maybe we can, well, if one of the three of you wants to comment first, and then we can jump in. Hey, Kathy? Kessel?
So I briefly mentioned a book that's in production, that's in honor of the 50th anniversary of AWM. That actually has so many articles about organizations for women in various countries, and I think that it's interesting to see the contrast. Marie-Françoise is one of the authors, and there are articles about the Organization for Women in Africa, an organization for women. I'm going to say organization, but it's really special interest groups, group of the organization, the Australian Mathematics Organization. And I think reading these articles suggests some of the contrasts of, that, and some of the things that one might want to consider in thinking about how creating an organization or creating a committee to support women in mathematics. And it's very interesting to hear what the different articles and authors have to say. And maybe Marie-Françoise, for example, had one of the considerations for European women in mathematics was the different languages and different currencies. Maybe you want to say more about that.
Yeah, no, I can say a few words. So first, there are really a lot of organizations, not only the Association for Women in Mathematics. Of course, certainly you started first, and you are also probably the bigger and more powerful, but there are many in Europe, of course, European Women in Mathematics, but also in India, in Africa, and now we are going to have a platform also in Asia and Oceania. So it's really, I can say it's really getting now everywhere, not to mention also in Latin America and so on. And in fact, a few days ago, we had a global meeting of the Committee for Women in Mathematics ambassadors, which are 150 people all over the world in about 100 countries. And they are kind of organizations or platforms or initiatives for women in mathematics in all these countries. So that's what I want to say. I mean, we don't. So we have now the website of the Committee for Women in Mathematics of the International Mathematical Union, and you can find a lot of information about what people do all over the world. And as Kathy mentioned, there is also the book, which is going to appear for the 50th anniversary of AWM, and there are several papers on that topic already. So that's what I wanted to say.
Right. Thank you, Kathy and Marie-Francoise. Linda, did you, I noticed you unmuted your mic. Did you want to make a comment on this?
Well, I guess my experience is not so relevant today. So, but I would certainly, if trying to organize women in a country which does not yet have an organization, to try to find who are the women, who are the prominent women in the field, and to get them on board, even if they're not willing to help in the organization. That's it.
All right, thank you. That's an excellent point. Okay, we have received a question from the chat. Joy asks, how does one know what area of mathematics to specialize in?
I mean, I think you just have to try a bunch. So I'd say as early as you can, try to get involved in research experiences with a broad number of different faculty over the years in different areas, take classes. If you don't have access to classes online, like whole graduate programs, whole undergraduate programs, whole high school programs are available for free online now. And so just go and dabble and see which areas have both questions and techniques that you're interested in. And I mentioned techniques because I love reading about history, but if I had to do the work of history, I wouldn't last very long. So that part's important too.
Excellent point. Kathy or Linda, did you want to weigh in on this one?
Yes, I don't want to be crass, but I think it's useful to find out what fields people are hiring in, because you do want to be employed after you get your degree.
Certainly a factor.
I'd also mention that sometimes it may depend on the availability and willingness of advisors, depending on one's situation. And sometimes I think maybe it's better to go with an advisor who is generally generally seems to be successful, whatever that might mean. For example, his or her students are productive. And this is just a conjecture, but I've thought of this sometimes because I believe, Linda, your advisor was Lipman Burrs, right?
No.
Oh, okay. I'm thinking of the other Linda.
But Lipman Burrs was certainly in the 60s the most productive advisor for female students. Quite impressive.
Right. Go ahead.
I didn't have so much help as a student, but I did have a postdoctoral advisor who really made my career.
Sometimes it's that connection that can do more for your interest and enthusiasm than almost anything.
Yes, quite true.
Okay, let's see. I have another question for you all. Based on your experiences, what advice do you have for young women who still see inequities in the way mathematician women are treated professionally?
So I'll just add one thing because it doesn't come up very often. I would say, so definitely, you know, talk to people and try to get help and get involved in organizations and things like that. But just to survive, I think it's really important to take care of your mental health. So, you know, get a therapist where you can talk through the rage that you're experiencing. I feel like if you can make yourself the best sort of version of yourself that you can be, it helps you to rise above just all the stuff that comes at you all the time, and keep yourself clear-headed and working on the things that you actually care about instead of getting mired down in all this other stuff.
I would completely
Very
agree
excellent
with
point.
that. I think it's important not to get upset at offhand comments made by other mathematicians. Through my career, I've found myself often in my early career, often very upset by very casual comments like, are you going to continue your career after you finish your PhD, or you're going to have children? Very, you know, it's just, or don't, if you want to get a job outside academia, just pretend you only have a master's degree. Very, very casual comments that just hurt. And over the years, I've tried to learn to ignore these things. I did try to get professional help at some point when someone had mentioned to me, well, in the difficult times of trying to get a job, well, why don't you try high school teaching? This was, and I talked to a therapist, and she said, well, what's wrong with high school?
Yeah, I think the rage that Catherine has mentioned is felt by many. Kathy, did you have any comments that you wanted to make for our young women in the field?
Well, I feel very out of it, but looking back on my own decisions, I think I would have advised my younger self to be much more pragmatic. Just think about, okay, maybe this person teaching you or advising you is not ideal, but are they getting the job done? And can you get through? Can you get to the next phase? And this is the sort of the flip side of thinking about, you know, the rage that some of us have.
It's a very, very excellent piece of advice, I have to say.
Yeah.
So I think, Marie-Françoise, you were going to jump in. I think we are at the end of our
Yes,
time.
I want to say something because we really need to stop now. I mean, for reasons, the person who's helping us with broadcasting needs to leave. So we need to finish the session now. So I would like to thank everybody and maybe mention that on the 24th of March, we are going to have the second webinar, which will be organized by another organization also on the gender gap in science. Okay, so I think we really need to stop. So
Thank you all very much. We appreciate your time. And I know for many of you, it was an odd hour of the day, and we appreciate your efforts to both participate as panelists, and I want to thank our audience for also participating at very odd hours.
thank you.